I'm Jesse with Mastercam, and today I want to show you the Add History function inside of Mastercam 2020. In previous versions of Mastercam, Add History was called Find Features. The name was changed for Mastercam 2020 due to the additional functionality that I will be covering over the next few minutes. For this example, I'll be working with this model of a chain guard. It was created in a separate CAD system and then imported into Mastercam along with the fixture. When a solid is imported like this, it comes into Mastercam as a brick solid. What this means is that the solid body has no history, so all the features of the solid, such as holes, fillets, chamfers, or bosses, are not displayed in the Solids Manager as separate operations that can be adjusted as needed. If I had a complex solid that was modeled in Mastercam, and I used the Remove Solid History function, the solid would be converted into a brick, just like our imported solids. Now, I can use Add History to make features of a brick solid into editable operations in the Solids history tree. In the Levels Manager, I'm going to turn off all the levels except the one with the fixture. The holes in the fixture are meant to accept 16mm bolts to hold down the part, but there's an issue. The holes were modeled as 16mm in diameter, which means they're oversized and won't be able to be tapped. Additionally, there has been a change to how the fixturing is going to be used, so I need to increase the diameter of the counterbore while decreasing its depth. For a drilled hole, I don't necessarily need to change the diameter of the hole in the solid. I could simply select the center point and use an appropriately sized drill. But if I need to use this model again in the future, or if someone else needs to machine this model, it's far too easy to mistakenly drill these holes incorrectly, since they are wrong in the model. It's a much safer workflow to correct the hole diameters now to avoid mistakes in the future, and Add History makes it easy to do. On the Model Prep tab, I'm going to launch Add History from the Modify group. The operation type is set to Create Operations. The Create a Single Operation checkbox means that all the holes of the same size or type will be combined into one solid operation in the solid's history. If I wanted each individual hole to be its own operation, I would disable this checkbox. Since I'm working with holes, I'm going to set the Find option to Holes. I know the holes in the model are 16mm, so I need to set the maximum radius to at least 16mm. If I was unsure what the diameter of my holes were, I could also right-click in either field and use the Diameter or Radius of an Arc functions. Being able to set a range for the hole radii to be detected is especially helpful when you're working on a solid that has a very large number of holes. I can now click OK, and Mastercam will display a report showing how many holes were detected in the solid. If I go to the Solids Manager, I can see that the solid operations have been added to the original solid. At this solid that was originally created in Mastercam. By double-clicking on the solid operation for the 3 bolt holes, the solid hole dialog is opened. I can change the diameter to the correct value, and my change is displayed in real time in the graphics window. After I close the hole dialog, I just need to go to the Solids Manager and click Regenerate. Next, I'm going to modify the counterbore. I can set the diameter, counterbore diameter, and counterbore depth to the sizes I need, close the dialog, and regenerate the solid. Back in the Levels Manager, I can turn the level for the chain guard model back on and confirm that the holes are now the proper size. Being able to add history back into a solid like this fixture means that any design changes in the future are much easier to adjust for, which saves a lot of time. This was a simple demonstration, but I'm sure you can appreciate how powerful this functionality would be with a large aerospace or automotive part that could have hundreds or even thousands of holes in need of modification. Hi, I'm Jesse, an applications engineer here at Mastercam. In this video, I want to show you the new copy functionality that has been added to push-pull inside of Mastercam 2020. Many times, it's easier to actually directly edit the solid model using model prep functionality versus using some of the older solids tools. In previous versions, you couldn't create a new body using push-pull, but now in Mastercam 2020, that's possible. Let's take a look. I'm going to start by splitting the solid face. I already have the wireframe that I need drawn, so I'm going to go to the Model Prep tab, and under the Direct Editing group, I'm going to launch Split Solid Face. When the function launches, it prompts me to select the wireframe and the face to split. I'm going to hold the Shift key while I select my wireframe so that Mastercam selects the entire chain and not just the entity that I'm clicking on. Next, I'm going to click on the solid face that I want to split. Solid Split automatically splits the solid face where the selected wireframe would intersect it when projected down to the face. Close the Split Solid Face function by clicking the green check. Next, we are going to go back to the Model Prep tab, and in the Direct Editing group, select Push Pull. Inside the Entity group and Push Pull, we now have two radio buttons. When Move is selected, Push Pull functions exactly as it did in Mastercam 2019. In Mastercam 2020, we now have the option to choose Copy. This creates a new solid body from the face that we select. With the radio button set to copy, I am going to select the new face that we created with Split Solid Face. To adjust the height of the face, click and drag the arrow. Since I need this solid to be the same height as the bottom of the head of the bolt, I will select an appropriate auto cursor position along the bottom of the bolt head. Click on the green check to close the push-pull dialog. If I click on the solid body that we created with push-pull, we can see that only that body is selected. This is a completely new solid body that is independent of the original solid. This new solid body is going to be used as a washer for the fixture bolt to hold down the part. So now we need to fill in this solid body. Since push-pull was the last function I used, I can press the space bar to relaunch it, or I can go back to the Model Prep tab and select push-pull. This time, we do not want to create a new solid. We want to modify the solid we previously created, so I'm going to set the radio button to move. I will then select the inside faces of the solid. With the faces selected, I will click and drag the arrow until the faces meet, creating a complete solid. I can now green check out and the solid body is complete. I can also change the color of this new solid body to help me identify it in my part file. So that's the new copy functionality inside of Push-Pull for Mastercam 2020. I hope you find it useful, and for more information, head over to whatsnew.mastercam.com.
Hi, I'm Jesse with Mastercam, and in this video, I'd like to show you a new enhancement to Productivity Plus probing, which makes it easier for new users. Starting in Mastercam 2020, you no longer need special post-processors or Renishaw machine files to post probing code. Instead, you can use the default mill machine in Mastercam. This makes it much easier for any user to demo Productivity Plus and get a feel for how it works. For this example, I'll be using this chain guard and fixture. The first side of this part is already machined at this point, so the part has been flipped so the other side can be finished. Now all I need to do is set my work offset origin for this setup. To do this, we'll utilize Mastercam Productivity Plus to measure the locating feature and then write the location to the G54 registry in the machine controller. On the Toolpath tab, I launch Probe from the Utilities group. Once the Select Probe dialog is open, I can edit the stylus and probe body to match the probe that I've configured at my machine. For this example, I'll leave this set with the default probe that is installed with Mastercam. If this is the first time you are using Productivity Plus, you will want to change the tool length offset and probe number to match your machine, or you'll get an error when posting. At this point, if I click OK, the probing dialog opens. To probe the locating feature, I'm going to click the Measure Circle function, which will prompt me to select a solid edge, arc, or line on the part. Previously, probing required wireframe geometry. Now you can set up probing with either wireframe or solid geometry. Once I've selected the solid edge, I can hit Enter to confirm my selection. Now that the feature is measured, I need to make sure my machine updates the G54 work offset. To do this, I'll click the Machine Update button. The update type needs to be set to WCS Update, and for the feature, I need to select the circle we just measured from the dropdown.
Since the measurement type was a circle, probing will automatically only use the X and Y coordinates. I can now click OK to save my settings, and the probing path will generate, so we can review it in backplot. As I mentioned at the start of this video, starting in Mastercam 2020, you no longer need special post processors or Renishaw machine files. I'm using the default mill machine, and with only a few clicks, I'm ready to post out my probing code. This means even a beginning Mastercam user now has the option to use probing to make their job setup at the machine faster, simpler, and more repeatable. Since only my probing operation is selected, when I click the G1 button to post my code, Mastercam is going to ask me if I want to post only this operation or if I would like to post out all operations. For this example, I'm going to post out only the probing operation. I'll give the posted NC file a name and click Save. The Renishaw posting dialog is automatically opened. In the Renishaw machine file path, you will notice that a default RenMF file has been selected. Prior to Mastercam 2020, these default RenMF files did not exist. These are what allows the default mill machine to post probing routines. Once I click on the process button and the code is finished processing, you should see succeeded at the end of the log output. I can now click Done, which will launch Code Expert so that I can review the G-code. What is produced is standard Fanuc NC code with the correct Renishaw macros embedded where needed. In prior releases of Mastercam, getting to this point would not have been possible without considerably more setup prior to posting. Please note that just like with any G-code, the defaults that are output may not work with your specific machine and controller as is. But for users who are new to probing or are using default machine files, these improvements take a lot of work out of getting probing up and running.